Speakers, we have Ankit Sharma, Network Engineer at Meta, and Juan Esteban, VP Solutions Architect at Benu Networks. Please welcome to the stage.
Good evening, everyone. Can you hear me? My name is Ankit Sharma. I'm a network engineer with Meta, and I'll be today taking you through Meta's involvement with TIP and how we are supporting the OpenBNG project. So this is the agenda for today. I'll start with a brief introduction of Meta's role with TIP and how we are involved in OpenBNG. Then I'll pass it over to Juan, who will be presenting the Benu network here. And then I'll finish with the testing that we are doing with for OpenBNG, and then some accomplishments that we have achieved in our testing. So as we all know that the Telecom Infra project has been very actively involved in developing open and disaggregated solutions for the community. With programs like OpenBNG, we are trying to revolutionize how the traditional deployments have been done. Meta has always been an avid supporter of open and disaggregated solutions. We believe that when we catalyze the early adoption of these technologies, we allow for evolved connectivity to be provided to the end user. This evolved connectivity will in turn help to bring the metaverse vision to life. Now the question arises why Meta is involved in a program like OpenBNG. One of the big reasons that we see here is that a lot of traffic that we have is still running on fixed line services. And BNG is an integral part of fixed line services. As we have seen before, the traditional BNG deployments suffer from issues like lack of automation and vendor lock-ins. So what we see is the BNGs of tomorrow, they need to be flexible and they need to be able to provide a good quality of experience to the end user. As Meta, what we are trying to do is we are trying to bring the ecosystem of OpenBNG, we are trying to mature it and help grow it. So for those who don't know what OpenBNG is, there are three ways that OpenBNG would differ from a traditional deployment. The first thing is we have decoupled the hardware and software component of the BNG. What that allows operators to do is you can pick and choose any software and hardware vendor that you want to deploy. And then on top of that, you can use open APIs to leverage and control that particular nodes. With this, I'll pass over to Juan, and he'll go through the next few slides with you. There you
go. Does it work now? OK. All right, so I have 10 minutes to talk about disaggregated BNGs and what we do. So let me just spend 10 seconds on Benu, what we do. We've been around for a few years, and we build virtualized and cloud-native virtual functions, network functions. So BNG is one of them, but we also build WAGs, CGNAT gateways, SASE gateway, and then we have an evolution to also 5G, AGF, and UPF. So really what we're seeing right now in the world is demand for high bandwidth from all these new apps, and also demand for low latency. So what this is doing really is we see that pushing the user plane to the edge of the network. And there's multiple topologies to do this. So there's different form factors in which this can be deployed. But we focus on that. We focus really on pushing user planes out to the edge. And in many cases, this is co-located with edge compute. There's multiple advantages of doing this. One of them is that we can break out as soon as possible and then minimize latency. And then this is a BNG user plane today. Tomorrow, this becomes an AGF plus UPF user plane. And then you can think about a metaverse slice, for example, coming from the prem to enable quality of service for those particular flows. So we're very much aligned also with Broadband Forum Cloud CO. When you look at the Cloud CO architecture, we play there as a BNG user plane. There's a control plane part, and there's an evolution to WWC, and then connectivity to the 5G core. You see there this concept of user plane, control plane separation, which really allows operators to optimize management. So now your subscriber management, your addressing, your distribution of subscribers across user planes, is much easier with this type of approach. However, we also see deployments where operators may be building pods or clusters in locations, and the control plane is actually taking care of user plane scalability within the POP. So, user plane, control plane really don't need to be kilometers away or 200 kilometers away. We've been testing that link up to 100, 120 milliseconds, no problem. So, it's very flexible. When people think about COPS and control plane, user plane separation, there's multiple ways to deploy this. But, I guess I just wanted to convey the idea that it's very flexible, and, the user planes, we're seeing this trend of pushing them out to the edge as much as possible. So now I wanted to talk to you about different deployment options that we have in our platform. The first one, it's running user planes and control planes as cloud-native network functions. This is our GA product, and this is what we are deploying today. And as I said, it can be control planes in central POPs and user planes on dozens of distributed POPs, or it could be clusters of control planes and user planes in the same POP. There's lots of options. So cloud-native means that user plane box that you see there is really run as a Kubernetes pod. So we run it as pods. We can run them on top of VMs, and they can be fairly small. They can be collocated with edge compute for a few thousand subscribers, so you can scale them out to a very large number of subs, and you can fit them in different ways into servers based on their resource. Just to give you an idea, today we're pushing 200 gigabits per socket on Intel Ice Lake, so getting to 400 gigabits on an Intel Ice Lake server, that's the state of art today, and we've come a long way in the past few years optimizing performance. So that is actually the solution that Meta has been testing, our COPS disaggregated approach. Cloud native is so much easier to test. Just drop the pod, configure it, and there you go, you're running, you can start getting call flows. Much easier to test than a physical-based BNG. Then from there, we also have solution based on white box. And I'll show you later a couple of more detailed slides on what we are doing. We're working with Eufy Space, Broadcom, Qumran 2C-based box. So it's a similar approach because we keep using COPS, TR459, between user plane and control plane. But now what we do is that we drop a container on the switch that does that, and it also integrates with a Broadcom SDK. From a control plane perspective, the control plane can manage virtual user planes, physical user planes, subscriber groups on both, and they are redundant running across them. So you could envision hybrid architectures as well. And then the last one on this slide is the integration on the OLTs. So we find operators and some of our partners looking at getting user planes on the OLT itself because it leverages maybe the same chipset. Maybe it's got a Broadcom Q2A, so the same SDK. That's going to scale to maybe 2,000, 4,000 subscribers on the OLT. It's a fairly distributed architecture. You end up with a larger number of user planes, but it's something that we're also seeing out there. Mixed vendor solutions. So we've been doing interoperability with large vendors. We can work as a control plane to third-party user planes, or we can be a user plane to a third-party control plane. Yeah? And then the last thing is we're the first BNG certified on AWS. So we run our user plane workload on AWS. It can be on a region, a local zone, or the outpost. So the outpost is on the customer prem. This can also run with EKS Anywhere, which is really like getting the AWS distro, the Kubernetes distro, and running it on x86. And in this type of solution, typically the control plane will be in a VPC in a region, in an AWS region. And of course, this is totally portable to Google or Azure. So you can see that there's a lot of flexibility when you think about deployments of BNG, with cloud native being super fast to test, and the other options also very viable. And with this, I'm going to show you what we've been doing, what we've been up to lately in terms of user planes. So our server-based user plane for BNG has been GA since 2021 with TR459. TR459 came out in 2020. We developed it, and it was GA in 21. That's the product that we're selling. So when you think about control plane, user plane separation, in some cases we can run on the same box because it's actually two different Kubernetes pods. We can run them separately. Like I said, it scales to a very large numbers of subscribers and throughput. And lately we've been working on Broadcom on the UFI space for a few months. So we've got it operational with, the beauty of this is that it's the same container running on the on the server-based solution and on the switch. So it's the same look and feel from a control plane perspective. You can visualize from an operations manager, our own tool. You can see the user planes, whether they're virtual, they're physical. And then we use Prometheus telemetry from the exporter client to the server. So we actually have been doing demos of this. If you want to talk to me later, I can walk you through this. We have a demo video of how this works. But essentially, getting 1K subscribers attached through the UFI space white box onto the control plane through our UPC. So the UPC to control plane is the COPS interface, and then the virtual user plane, same thing. One of the caveats here is that we still don't have NAT supported on the UFI space. So we have a very large scale when it comes to NAT. You really need to support 100 million NAT flows, or maybe more on a user plane. So we find that it's easier to do that in software these days. And then, of course, when it comes to so what I was showing earlier, this is really like control plane packets, so your PPPoE or your IPoE attachments. And then when it comes to the traffic, of course, the data path on the UFI space is through the Q2C chipset. In the virtual or the containerized user plane that runs through a dedicated container that can be made larger or smaller. One of the great things about that solution too is that they scale in and out based on traffic demand. So you could think about time of the day pods being flexibly adapted. And in that case, the fast path is actually through the DPDK user plane. And lastly, we use a common approach to collecting stats and pushing them up to our operations managers, so that all this, it doesn't have to be ours, by the way. This is Prometheus. We're working on GNMI as well, so this integrates with third-party systems out there. Yep, and that's all I had. I pass it on to Ankit. Yep.
Thanks. So in order to be actively involved in OpenBNG program, Meta has been leveraging our labs. We have 2 labs, one in California, one in Singapore. In our testing with OpenBNG, we have used both open source and commercial traffic generators. We have white boxes from multiple suppliers that we have been using for testing. Now, having these boxes from multiple suppliers has enabled us to also test interoperability between the elements. And also, as we all know, there was a shortage of hardware and silicon in the past few months. So in order to keep our testing ongoing, we have also used virtual BNGs, for example, from Benu, to keep our testing activities ongoing. So in order to give back to the TIP community, we have been working with multiple partners to develop an extensive test case, test plan that can be used for OpenBNG testing. Now, this test plan incorporates all type of OpenBNG deployments, edge, core, and access. Getting input from operators, we have been able to prioritize our testing on the critical and essential features that the operators would need. Now, our testing doesn't stop there. We keep on testing any new features that the suppliers would introduce. So the test document will be updated as we go along. One of our mottos is to move fast. And as I had mentioned before, due to the lack of the hardware that we had, we did not stop our testing. We kept on moving fast, and we used virtual BNGs to keep on testing. Now, this test plan would be available for the PG group members in the coming months. You're welcome to have a look at it when it's available. This is one of the test case scenarios that we have tested in the lab. It's a basic BNG session establishment. Now, as we can see, any feature testing on a BNG is a multifaceted approach. So some of the features are hardware dependent. Some of them have less dependency on the hardware. So for example, if you want to authenticate, if you want to check the validation of authentication of a user, and whether it's to a local or a remote radius server, we are not very dependent on the hardware. But if I want to attach a physical CPE to the box, or if I want to test something like a maximum session setup rate for PPOE, then I'm dependent on hardware. So what we can observe from this is that in order to begin our testing or continue with our testing, we can use both virtual and hardware solutions that can help us with that. So these are some of the accomplishments that the team has achieved over our few months that we have been testing OpenBNG. Since we had support from multiple suppliers, we have been able to get multiple white boxes. We have tested multiple hardware architectures. Again, with hardware architectures, we have also tested virtualized solutions from Benu networks. As part of supporting the TIP community, we have also developed various runbooks. These runbooks can be used to execute the testing of OpenBNG in the near future. The idea is that the operators can use these runbooks and they can execute the testing activities that they want to perform, and these runbooks will help them to run those activities very quickly. Now, since our lab had a presence of various vendors, we have also leveraged that architecture to test the interoperability between the BNG providers as well as other vendors that we have, the traditional BNG vendors. And after our testing, we are very confident that we have a diverse and strong ecosystem of OpenBNG suppliers, and we are looking forward for any field trials in the future. Thank you.